Okay, here's a problem from chapter 11.6. This is number 14. This is a good question because it covers a lot of what we learned today as far as areas go. There are 6 pictures, and all 6 pictures are asking you to do is to find the area of the shaded region. So we're going to start with the first row. It's A, C, and E, and then we're going to do the second row, which would be B, D, and F. So the first row, for number 14A, you got a square with a circle inside. You're trying to find the area of the shaded. So again, always we come up with a plan. So I'm just going to come up with a plan for each of these to start. So I got a square surrounding a circle. So it's going to be the area that I want is going to be the area of the square minus the area of the circle. Okay? So that's letter A. The next one, I got, again, a square, because again, I can assume regular polygons. So I know that if it looks like a square, it's going to be a square. If it looks like an equilateral triangle, it's going to be. For the next one, I know that it's a square, so it's going to be the area of the total. It's going to be the area of the square. It's the big thing. And it's going to subtract the area of 4 sectors. Okay, and then lastly, the area of this thing is going to be the area of the circle. All right, I'm going to subtract the area of the square inside. Okay, so coming up with the plan for each is pretty important because now you have a goal in mind. So what do I want to find? For the first problem, the area of the square is real easy. Since it's a square, it's side squared. The area of the circle is a little bit harder, but looking at this, you know that the circle is going to have a radius of 5 because the radius of the circle is also like the apothem of the square. If you remember that word from today's lesson, the apothem is the distance from the center to the edge of the square. Well, the apothem of the square is the radius of the circle, and the radius gives you the area. So the formula in exact form is 100 minus 25 pi, and that's good for number 14A. The next one, the area of the square, again is 10 squared, very simple, but now I got to find the area of 4 sectors. So each sector, since it's a square, has a measure of 90. Each sector, since it's a since these go to the midpoint, is going to have a radius of 5. So I got 4 sectors. Each of them has a measure of 90. 90 over 360 times pi 5 squared. Okay, so what I get there, basically 4 times, this is going to come out, this right here is like 1/4, so 4 times 1/4 actually cancels those out entirely. You could just plug it in your calculator, but just so that I don't have to, I know that little trick, so it's 100 minus 25 pi, and it looks like the first 2 questions have the exact same area, which is kind of interesting. But I guess if you look at them, they look kind of like, they could, and if you think about it, it kind of makes sense. The last one, the area of the circle is a little bit tricky. So the side of the square, the area of the square is going to be easy. Again, all 3 of these have a square of side 10. So the area of the square is going to be 10 squared. The area of the circle is going to be a little bit trickier. But if the side's 10, the diameter or the hypotenuse or the diagonal of the square is 10 root 2. And that would make the radius of the circle 5 root 2. So if you're having trouble seeing that, basically what you have again is a 45, 45, 90, because it's a square. 45, 45, 90. So the diagonal is 10 root 2, which makes, that's actually the diameter of the circle, which makes the radius of the circle 5 root 2. So this is what I got. Area of the circle is going to be 5 root 2 squared times pi. So I'm going to do this. 5 root 2 squared is 25 times 2, so this is going to be 50 pi, and then minus 10 squared, so minus 100. So those are letters A, C, and E from number 14. Let's move on and continue with these problems. And here are B, D, and F from the same question, number 14. So again, I'm going to come up with a plan. In this one, the area that's shaded is going to be the area of the equilateral triangle minus the area of the circle inside. Okay, in this one, we did one very similar to this in class. This is going to be the area of the equilateral triangle minus the area of 3 sectors. Okay, and again, if you're having trouble seeing why, slow it down. You can look back and just try to understand what you're doing. You're taking the total area of the shape minus the unshaded. And then lastly, I got the area, it's going to be the area of a hexagon minus the area of the circle inside. So let's let's go with this, see if we can do it. All right, so looking at B here, this one, equilateral triangle should be easy. It's just side squared root 3 over 4. So in this case, since the side is 10, it's 10 squared root 3 over 4. That's going to be the easy part. Finding the area of the circle, once I find the radius, will be easy, but that actually is the trick to this problem. So looking at that, I need to find the radius. And if you look at that, the radius of the circle is also the apothem of the triangle. Okay? So looking at that, since I know, let me make this a little bit bigger so that I can see it better. All right, so since I know that the side is 10, and I know if I split this thing up, that's a special right triangle. All the angles in an equilateral triangle are 60, so when I split that, it's going to be a 30, 60, 90. And it's actually going to be 30, 60, 90 with the long leg 5. Okay, this is a little bit tricky. So now that I know the long leg, I can tell you the short leg, which is actually the radius of the circle. So the short leg is 5 divided by root 3, using my properties of 30, 60, 90, which means I get 5 root 3 over 3 for the radius. So then the area of the circle is going to be pi 5 root 3 over 3 squared. There isn't any easier way to do it. Okay, the radius of the circle is the apothem of the triangle, which is 5 root 3 over 3. A little bit tricky there, but that's how you do it. So you get here 100 divided by 4 root 3 is 25 root 3. Here I get 5 root 3. Squared is going to be 75. So basically this comes out to 75 pi over 9. That's the final answer. Okay, just let me check that real quick. So again, you distribute this. 25 times 3 is 75. Distribute the square to the 3 is 9. Okay. Next one, area of the equilateral triangle, again, 10 squared root 3 over 4. The area of the 3 sectors, we did this one in class, I think the exact question with 10 and everything. So it's going to be 3 times 60 over 360 times pi 5 squared. So again, if you missed this one in class or didn't get it, make sure that you kind of look at this one closely. But again, this is going to be the same as the last one, 25 root 3. Minus 3 times this, it ends up getting, you multiply it all out in your calculator, 3 times 60 over 360 times 5 squared. Don't touch the pi. Put the pi back on later. And you should get 25 over 2 pi, or you left it 25 over 2 as a decimal, would be 12.5 pi. All right, so that was number 14D. And then lastly, you got F. So that hexagon now has the formula, it's 1/2 apothem times perimeter. The circle is pi r squared. So I need a few things. I need the apothem. And we talked about this in class. You know, if the side of the hexagon is 10, the apothem is 5 root 3. I also know the perimeter of the hexagon is going to be 60 because it's 6 sides all 10. So therefore, very quickly I could find the area of the hexagon using the formulas that I learned today. You also recognize that the apothem of the hexagon is the radius of the circle. So this is going to help me with this part too. So after you find the apothem, you pretty much got everything you need because you just needed to multiply the side by 6 to get the perimeter. So now I get 1/2 5 root 3 times 60 gives me 150 root 3. Pi 5 root 3 squared gives me 75 pi. Okay, so those are 6 questions that I really thought tied everything together from 11.5, 11.6, and even the idea of area of the shaded region before that. So hope that helps. You complete your homework.